Yeah, so hello everyone, good evening, and welcome to K.R.A.I.G 201. So my name is Ajay Yogendra. I'm a subhead at Technology Robotix Society. So before we begin, let me just give you a small introduction of what K.R.A.I.G actually is. Okay, so K.R.A.I.G, K-R-A-I-G, is an acronym for Kharagpur Robotics and Artificial Intelligence Group. So it's a technical body under Technology Robotix Society. So basically, the group K.R.A.I.G is responsible for holding many workshops like K.R.A.I.G 101, which already happened previously, and K.R.A.I.G 201, etc. So these workshops are basically focused on many interesting aspects of robotics. Okay, so as you all might be knowing, in our previous workshop, which was K.R.A.I.G 101, we covered many important aspects about manual robotics. So in that, there were many topics like differential drive and many other types of mechanisms like forklift mechanism, rocker bogie mechanism, etc. Okay, so in this session, we'll be diving deep into the world of autonomous robotics. So it will cover many things about sensors, actuators, a little bit about Arduino Uno. Okay, so everything about autonomous robotics. And at the end of this session, we'll be having a virtual hands-on session in which in which you will actually get to put the knowledge which you gained in this session to practice. And we'll be guiding you. You'll have your mentors who will guide you through the session. You might be knowing you already got an email regarding the virtual hands-on session. There's a separate team called K.R.A.I.G 201 Virtual Hands-On. Okay, so the session will happen there right after this session. Okay, and also at the end of this session, we have a small surprise for you. Okay, so that the surprise is basically for those freshers among you who are really interested to explore robotics right from the comfort of your homes. So stay tuned for that surprise to the end. Okay, and in the during the session, we'll be holding many trivia sessions. The ones among you who have attended K.R.A.I.G 101 might already be knowing this, that in order to organize those trivia sessions, we'll be using a website called Slido. So you'll get a link in your chat box, and you can access the Slido's link from there. Okay, let's move on. Let's begin. Yeah, so what is autonomous robotics? So you might be getting an idea what kind of robots might be classified as autonomous robotics right from its name. So I'll just give you a minute to think, and you can give your responses in your chat box about what you feel an autonomous robot should have. I mean, what characteristics does an autonomous robot have? Like this intuition is really important, first of all. So any one of you? Programming a robot to perform on its own. Okay. Yeah, exactly. So the human input is not needed. So an autonomous robot basically functions on its own. Like there is no manual control involved. Like in the previous session, we saw many aspects about manual robotics where you need to give the control to the bot. But an autonomous robot, as this slide shows, works independent of any controller. And in order to do such a kind of thing, to work independent of any controller, it has to take a stimulus. I mean, it has to respond to the stimulus around itself in a certain way. So this working of the autonomous robot will involve many steps. Like first of all, it has to sense what is there around itself. It has to sense and based on that it has to do something in a certain way which is useful for the end user. Okay, in this picture you can also see a rover. So it has many things like, for example, a pan tilt zoom camera and a webcam and these gears which you see. These are the end, I mean, actuators, and you'll see what actuators are in the session. So yeah, fine. Let's go to the next slide. So here we have an interesting video for you. So as you can see, this bot is an example of a line follower bot. So it's actually following the line without any manual control. Like there is no manual control involved. Like there is no one who is, there is no remote control, etc. Like it's on its own, it's detecting the line and following on its own. So in this session, you'll actually get to know what kind of things actually go into making such kind of bots. So right after the line ends, you'll see a different kind of control. The bot will then try to follow the wall using those dots which you see. So yeah. Hope you liked that video and got the motivation of what actually is an autonomous robot. Okay, so now I request my colleague Vinayak Agarwal to take over. Over to you, Vinayak.
Hello everyone, I'm Vinayak. I'm a sub at Robotics. So I hope you got an idea of what an auto robot means, right? Now let's get a general idea of the working of an autonomous robot. So an autonomous robot is supposed to function completely on its own, right? By interacting with surroundings and responding according to it. So for this to happen, the bot must have a sensory wing that involves all the sensors, and that wing interprets all the outside happenings into signals that could be understood by a computer. Okay, so there's a sensory wing which has all the sensors. Next, there is a controller board that receives and stores and then commands the bot according to the logic that we feed to the controller. So this part of the bot is responsible for all the logic part and actually doing it. Okay. And lastly, there has to be a part responsible for all the mechanical output, like actually making the bot move and the motion of the bot and stuff like that. So we call that part as the actuator part. So there are three wings: sensory wing, and the controller, and the actuator, right? Uh, Slightly informal way of how you can think of actuators is the part of the bot that doesn't involve the processors and the sensors. For example, in a bot, a motor is an actuator, but a tracker module that is installed in a bot is not an actuator. Okay, so I hope you have a pretty good understanding of the general idea of the working of an Autobot. So with that, let's have a quick trivia. Okay, so there's going to be a Slido link in the chat box. Also, you can go to slido.com and use this code, and you can also scan this QR code. So everyone, go to this link and answer the question: which of the following is an actuator? Okay, we have 23 responses till now. We'll wait for 1 more minute. Mm, okay, let's just wait till 50. Okay, so we can have the answer now. Let's see how many of you got it right. Yeah, 77% people said that it's a servo motor, is an actuator. Okay, okay, so let's have the answer now. Yeah, so servo motor and relay is the correct answer. See, accelerometer is a sensor. GPS module is also a sensor. It's a tracking module. Intel i4 Pentium is a controlling unit. Servo motor and relay is the correct option. Servo motor. I even gave the example of motor, and relay is a switch. So um, yeah. Okay. So okay, guys, you can stop the poll now. We have the answer now. So based on this, I think you have a good understanding of the working of an autonomous robot. So, as I said, there are three wings, like sensory wing, the controlling wing, and the actuator part. So, you have a good understanding of working. Now, let's have a look at the sensors. Okay, so what is the sensor? Suppose you want your computer to know the temperature of its surrounding. You'll need a temperature sensor, right? So, the temperature sensor can sense the temperature and share this data with your computer. As simple as that. So, how do you define a sensor? Sensor is an input device which provides an output signal with respect to a physical quantity that acts as an input, right? So there's nothing much to tell here. Let's have a look at let's have a look at some commonly used sensors which are very popular in the robotics world. So first we have IR sensor. Okay, so IR sensor is infrared sensor, and the most common application of it is to detect objects. So there are two types of IR sensors. We'll talk about it later. But there is IR sensor and there is a passive infrared sensor and there is an active infrared sensor. Active infrared sensor is IR sensor, that's what we call. And PIR sensor is passive infrared. Moving on, we have accelerometer. Okay, so accelerometer basically senses the acceleration forces acting on it. So it helps in determining the acceleration and everything. It's used in variable objects in sports and in cars, and it's also used to determine the orientation in the gravity plane. And yeah, okay, so let's move on to the next sensor. Temperature sensor, as I just told, is used to sense the temperature. Also, it's very intuitive. Next sensor is the force sensor. Okay, so the force sensor is used to determine the mechanical load experienced by it. So suppose you have to make a weighing machine, you use the force sensor in it, so it can determine the weight. Moving on, we have GPS sensor. So GPS sensor, I think all of you must know, is used for tracking the project or whatever you are making. And the last sensor we have is the color sensor. So again, as the name suggests, it is used to detect the colors. So it can be used in a camera, or it can be used to, you know, define the object or whatever is your project. Okay, so again, I think you all must have a good feel of what a sensor is, and you must be able to tell now that what kind of sensor must be needed in what kind of situation. So again, based on this, let's have a quick trivia game. Can you name the various sensors present in a modern day smartphone? Again, use the Slido link. It's in the chat box. Also, you can use this code on slido.com. Hurry up, guys. Okay, meanwhile, people are answering to the poll. I think I forgot to answer some questions in the chat box. So I think a few of them is answered. Okay, so yeah, on which part of the force sensor? Okay, yeah, it's on the circular part, and uh, but technically, actuator is not responding to stimuli. It's not. It's just receiving instructions from controller. Yeah, actuator is just receiving instructions from the controller. The sensor is taking the information from the outside. So basically, that is taking the stimuli. Like it is sensing the stimuli, and the controller is actually giving the instructions to the actuator. Actuator is not what responds to the stimuli. The bot is what responds to the stimuli. Okay. Okay. So we have 56 responses till now. So we can have the answer now. Okay. A lot of people told accelerometer, GPS sensor, gyroscope, yeah, touch sensor, fingerprint sensor, yeah. Uh, a lot of these answers are right. So, well done, guys. Let's have a look at the answer now. Yeah, so I saw camera, accelerometer, gyroscope, and GPS in the answers. So, camera, we all know, captures images. Accelerometer, it's used to detect orientation and movement of devices, and it enables important features like shaking the phone to change songs and those gestures. Gyroscope is you must have heard it in your JE preparation to detect the angular velocity of the phone and the angular position. Light sensor is used to detect the intensity of light falling on the phone, and proximity sensor is used to turn off the phone when phone is brought to the ear. Hall sensor is used in compass apps, and GPS we all know to detect phone's location. Okay, so that's nice, guys. Everyone has a good understanding of sensors, I think. So that's yeah, okay. So that's pretty much it with the commonly used sensors. Now, amongst these, there are two majorly used sensors. We'll have a look at them now. So these are ultrasonic sensors and IR sensors. Now, let's have a look at ultrasonic sensor first. Okay, these two sensors, ultrasonic sensor and IR sensors, are like widely used in robotics. Like you'll be using almost in all of your projects at least one of these two sensors. Okay, so ultrasonic sensor. As the name suggests, it uses ultrasonic frequencies to detect something. So what ultrasonic sensor does is it uses this sound waves to detect an obstacle. So it basically has two transducers, a transmitter and a receiver. And the transmitter transducer is called a speaker, and the receiver transducer is a microphone. Now, the sound wave operates in ultrasonic frequency range that is around 40 kilohertz and is not audible to human ears. Okay. So, what it does is the sound wave comes from the speaker, it goes on, and once it finds an obstacle, it reflects back, which is now called the echo, and the receiver receives it. Okay, so this is a similar concept that is used in radar. What's a radar? A radar, like suppose on an airport, uh, radar sends out a lot of pulses, sound pulses, and once they hit an aircraft or something, a part of them gets reflected back to the transmitter, where there is also the receiver. So that way it knows there is a obstacle, right? So it's a similar principle to that. Now, you don't just want to determine if there is an obstacle, right? You can also know the distance of the obstacle. So you know the time of the pulse that got transmitted and when it got received. So the distance will be half the time into speed of the sound. So that way we can determine the distance. So ultrasonic sensor is very commonly used to determine the distance. So here we have a good explanation of an ultrasonic sensor. Before that, just note that there are four pins. Like there is VCC, trigger, echo, and ground. So let's have a zoom in look of the working. So there are these four pins, and there is this controller unit. So the controller unit sends a voltage pulse that triggers the ultrasonic sensor. Okay. Now, when the ultrasonic sensor is triggered, the transmitter or the speaker sends out a sound wave. Now, this sound wave, when this sound wave gets hit by an object, it reflects back. Now, once the receiver detects this reflected sound wave, it again generates a voltage pulse, and the voltage pulse is now reached to the controller unit. Now, the controller unit can calculate the time taken in between the both the pulses. Okay, so that way we can know the time taken uh, by the sound wave, and that way we can find the distance. So I guess that's pretty intuitive till now. Yeah, I think that's it for ultrasonic sensors. If you have any doubts, you can ask now or ask later also. Let's move on to IR sensor meanwhile. Okay, so IR sensor or infrared radiation sensor is one of the basic and popular sensor modules in an electronic device. It can be used to detect obstacles. So there are, as I said, there are two types of IR sensors: active IR sensor and passive IR sensor. So the sensor shown on your screen is active IR sensor. So it has a transmitter and a receiver. Well, the receiver is actually a photodiode, but it can be thought of as a receiver. Now, similar to the ultrasonic sensor, it will emit radiations, but this time they will be infrared radiations, not not sound waves, and they will reach an obstacle and they will get reflected back if the object's body is reflective in nature, and the receiver will receive it and then will send an output accordingly. Okay, so let's have a deeper understanding with the help of a circuit. Now, this circuit might look complicated at first, but it's really not. So I won't explain the whole circuit right now, but I'll just give an idea. So can we go to the previous slide again once? So there are these three pins on the IR sensor, right? The leftmost is the VCC, the voltage pin. The middle one is ground, and the rightmost is the output. Okay, so let's again go to this circuit. So we supply plus 5 volt to the VCC. There is a ground, and the IR transmitter is basically the IR LED. There is the IR receiver, that is the photodiode. Now, this triangle thing is the op amp. Okay, it's also called as a comparative. Now, when the current reaches the IR transmitter, it transmits IR signals. Now, once they reach an object and they get reflected back, the photodiode gets activated, right? So the resistance will drop down. So the voltage between the R2 and the photodiode will decrease, right? So knowing this, now let's see what happens at the op amp. Now the plus VCC is actually the plus 5 volt, and there's the ground, and you can see those two plus and minus, right? They are marked as 2 and 3. So basically, they are called as inverting and non-inverting pins. The the pin marked as 2 is the inverting pin, and the pin 3 marked is non-inverting pin. You'll get to know what it means in a short time. So uh, in the pin 3, there is a constant voltage applied all the time. Okay, that's gained with the diagram shown. And once the radiations from the obstacle come to the receiver, the voltage changes at this point between the R2 and the receiver, right? So the logic of this op amp is, if the voltage at the non-inverting pin is greater than the voltage at the inverting pin, the output will be high. That is one. And if the voltage of the inverting pin is greater than the non-inverting pin, then it will be low. That is zero. So at 7 we will have 1 and 0, and this will be connected to the controller board, the logic board. Now if the output is 1, we know there is an obstacle, and if the output is 0, we know there is no obstacle. Okay. And the further circuit is R3 with the LED. It's just to see check if there is an obstacle or not. Like you can have an indication on the IR sensor itself. So if there is an output, if the output is 1, then the LED will glow. If it's not, then the LED will not glow. This is it for the circuit. Now you can see there are two IR. Can we move to the, yeah? So basically, this is an IR LED. Now this looks like a normal LED, right? Like you can't tell the difference by just seeing it. So it's very similar to the normal LED, like it works on the same voltage and current and everything. But the difference is that it sends infrared light, so you can't see it. And the picture on the right is the photo of a photodiode. And yeah, okay. I think that's pretty much it. Now you have a good understanding of sensors and the basic working of a autonomous robot. If you have any doubts, you can ask now in the chat box. Are there any doubts? Okay, even if you have doubts later, you can just ask them in the chat box. So, in the meanwhile, I'll hand it over to Manideep, who will continue further. Manideep.
Yeah, hello guys. My name is Manideep and I'll be continuing next. So, like as Vinayak explained now, you got the basic understanding of all the actuators, so all the sensors. Um, so in as you can see in the last IR sensor explanation as well, like all the sensors take up different physical data and then converts them into electrical signals and then passes on to the a bot. So like whenever a sensor passes on electrical signals, so you have to process them to understand what it is and then proceed further, right? So that's where logic unit comes in. Logic unit is the core or the most important component of any robot or any electronic system. So because it is the brain of the whole system. So let's say a simple example will be a microphone where a microphone senses the pressure differences and converts them into electrical signals, that is just spikes, then ones and zeros, electrical spikes. Electrical high voltage is called 1 and 0 voltage is called 0, so that binary, and that information is will be sent to a processor and processor processes it, and along with that everybody knows that we also write code, and code is also converted into ones and zeros, and that is also been processed with this with the same microcontrollers, the processors, and then we give a signal which is also a binary signal to actuator, and that does something in the real world. So that is a basic understanding. And okay, so what is the difference between a microprocessor and a microcontroller? So microprocessor is the actual integrated circuit that actually does the processing, and it also requires some peripherals like a RAM, for example, in a computer, or a small memory chip in case of smaller microcontrollers, a RAM, some USB control systems, a small amount of storage, and all this combined is called the microcontroller, and microprocessor is the actual processing unit. Um, that like what peripherals do you think there are? Like there are clocks, there are timers, there are ports, and there are obviously RAM, storage, etc. Um, okay, so how do we work with these microcontrollers? Like for example, if you want to build some, if you remember the line following bot, we need some processing. We are getting information from the ultrasonic sensors, and we have motors to move the robot. But we need something else as well to actually understand and give signals to the motor, right? So that's where the microcontrollers come in, and we need them. But the problem with the microcontrollers is that it is not very easy to use because they are tiny chips and you need to program them. And of course, like robotics enthusiasts, advanced robotic enthusiasts actually directly work with the controllers and directly program them, but it's a very complicated process. So the companies like Arduino and many other companies actually um, came up with this idea called microcontroller boards. What this is like? They use one of the microcontroller and attach it with the various components and make it user friendly for everybody to use. For example, let's go to the Arduino as an example. Um, Next slide. Yeah. So if you see, Arduino is an open source project. They provide generalized schematics that are open for everybody to actually make the circuit boards. They have many versions, Uno, Nano, Mega, and many other models. Arduino Uno is the most user friendly and the most famous one. So what it is, what is an Arduino? So if you zoom in, yeah. Um, or if you see like in the previous slide, you saw the microcontrollers, right? So if you see in here as well, the large rectangular black block is the actual microcontroller, and rest everything is the peripherals which actually help to make the process easier. For example, Arduino comes with a USB port, a power supply, a clock, a timer, and microcontroller, and some many ports to actually easily connect with this. And it also, most importantly, it also comes with a IDE. You know IDE, right? Like IDE is integrated development thing. So it is basically, um, let's say, if you want to program a microcontroller directly, you need to use AVR programming. That is basic. It's almost writing the code in binary, which is incredibly difficult. So what Arduino came up with is a coding library that you can that looks like English. Like you can see in the right. That is actually the Arduino IDE. It can be installed in any of your computers, all the platforms, Linux, Windows, and Ubuntu, and so this you can download this, and there is a small syntax that you need to learn, which is very easy, and there is a documentation available on the Arduino website. And once you did that, you can easily write code and actually connect the Arduino itself to the your computer. There is a USB port, so you can directly connect and directly transfer it. You can code the Arduino in seconds. So that makes the life that makes in like beginners robotic beginners life very, very easy. This is kind of a dream come true situation. So yeah, that is a basic idea of your Arduino, and I'll explain you how it works in the next slides. This one. Yeah. So just give you some specifications. Yeah, zoom in. Yeah, to give you some specifications, um, Arduino comes with a power supply. That is, it powers the microcontroller and the other components on it. So you need a 5 volt you need to provide a 5 volt power supply to the power to the Arduino itself to actually run it. And To start with, that 5 volt power supply will be split into two other power supplies. Like it's a power distribution is also happening inside this, and that converts into 5 volt and 3.3. So you can see there is a 5 volt pin and a 3.3 volt pin. So you can use these 5 volt and 3.3 volt pins to actually power your devices like sensors. But yeah, and there are ground pins obviously, and as it okay, that's the right left side upper block. Okay, now if you see left lower block, that is A0 to A5. Hmm. So these are the analog input pins, and the right side is the digital input slash output pins. So what is the difference between an analog pin and a digital pin? It is as simple as that. Like analog pin is a, so if you voltages come from 0 to, for example, in Arduino, the maximum voltage limit is 5 volt. So voltages come from 0 to 5 volts, right? So digital pins can only understand two stages, that is less than 2.5 volts and more than 2.5 volts. That's it. There are only two levels, that is high and low. It can't differentiate between 2.5 volts and 3 volts, for example. But in case of analog pins, there is an analog to digital converter inbuilt in the Arduino board. That can, these A0 to A5, the six pins can understand the difference between 2.5 and 3 and 3.2 and 3.5, everything between 0 to and 0 to 5 volts. So these analog pins can be used to take input from a sensors like temperature sensor or sound sensor or something like that, where you need a continuous input. But for example, if you're using IR sensor or for example IR sensor, in that case it's just whether there is light or not. In that case, you only need two stages, that is on or on. Though in that scenario, you can use digital inputs. And one more interest. Okay, that is input. For example, you can say you're getting analog input and digital input. But what about the digital and a digital output? You can use the same pins, but digital output is little complicated. Um, Sorry, analog in the output is a little complicated. For example, um, if you want to give 3 volts instead of 5 volts, um, there is actually no way that, like, do you need a different power supply and whole circuitry to actually provide 3 volts? So that is not possible because for example, okay, I can make a circuit for 3 volts. If I want 3.2, I have to make another circuit. If I want 5, I can 3.4, I need another circuit. So it becomes complicated and it's not practical. So if you see on your right, pin 11, 10, 9, 6, 5, 3. So there is a tilde sign on the side of those pins. So what does that mean is that these pins are PWM enabled. Okay. PWM is nothing pulse wave modulation, and the theory is little complicated. I mean, I can explain it, but yeah, let's leave that. You can Google it and you can see how PWM works in your free time. So it's a innovative way to actually fake 3 volts. Like if you want 3 volts, you turn on and off the digital pin, and like if it's like average, on average you it's only 0 and 5 volts, but you on it and off it for a while and then turn it on, off it for a while and turn it on, and on average, like over a minute, it will be 3 volts on average. So it's an interesting concept. You can learn about it later. In that way, you can use PWM and generate different like the analog voltages using digital pins. All right. Okay. Mostly that's all about the Arduino itself. And if you see, there is one LED connected. The positive pin of the LED is connected to the 13 digital pin, and negative side is connected to the ground through a resistor. So that is a basic connection. If you go to the previous slide, there is a code written. Can you go back one slide? Yeah. So this code, so if you can see, code is very simple. Starts with the void setup, that is setting up the Arduino. In that case, your pin mode is a function that sets whether pin is output or input. In case of LED, where there is no input, LED needs output, like it needs a power to actually work, right? So you set it as output, the LED built in. So 13th pin is actually there is a built-in LED as well. So 13th pin is named LED built-in, and that is set to output. Okay, and then setup is done, and now we come to the void loop. Loop is just whatever you write in the loop. When you run the program, if you're in uh, chemistry sem, you're probably doing this in your PDS course. So when you run this program, setup is a function that runs once because there's no loop involved, and after that, after the setup, the loop repeats infinitely until unless you turn off the program, right? Because there is no exit. So what's happening in the loop? There is a digital write, that is a function. It's built-in function. Like all these Arduino IDE provides all these, and you can see what all functions are available on in the IDE itself, and there's a documentation you can refer it when you work on. So digital write, that is you're telling the pin what to do. That is LED built-in pin high. So you're turning on and then waiting delay 1000, that is 1000 milliseconds, that is 1 second. So you're waiting for a second, and then low, that is turning off and then waiting for a second. So basically when you write this program and upload it to the Arduino and connect the LED in the way that we did in the next slide, uh, it just blinks. So this is a code to make the LED blink. So it's as to make the LED blink. This is as easy as this because of Arduino. If you were not using Arduino and you want to do it manually, in that case you need to get your own what you need to get your own USB controller, your own microcontroller, own or power supply, own clock, own timer, and then connect all these, and then you do your AVR programming, and then you'll be able to blink the LED. So you don't need to do all that because Arduino already does it for you, right? So that makes life easier, right? So that's all for the Arduino. We'll move on. Yeah, next. Yeah, here's your trivia question for you. I think you already saw the code. It might be familiar for some of you. So yeah, go to Slido and answer the question. What language is typical Arduino code based on? Like it might be familiar for some of you. I mean, it's not exactly that, but it's based on one of these languages. Okay, I'll answer the questions. In Arduino, what if I want to go to perform limited number of loops and stuff thereafter? What would be the change in? Yeah, you can absolutely do that. You can exit the loop and make another loop next after that loop. There's no problem with that. You can do that. It's up to you. But usually, like it is not a. You won't use Arduino to do some specific task for a minute and then leave, right? Hmm. Yeah, like there is no main as such in Arduino code. Like as I said, it's not exactly Python, Java, or C, C++. It is similar to that. Yeah. Most of the cases, Arduino is something that you use in projects that is continuous. Like you don't do it for one particular time limit and then leave the project, right? For example, if you're using it to some home automation setup, you want it to work for entire time until and unless you turn it off. So in 99% of the cases, you need that an infinite loop, and obviously you can stop it and terminate the program. Nothing wrong with that. Yeah, we got enough 60 responses. We can see the answers. Let's go. Yeah, correct. Like I mean, like you saw the void setup and the curly brackets. Yes, of course it is C++, C++, right? Let's go next. That's nice. Okay. Okay, let's move on to actuators. So Vinayak explained the sensors. That is you sense the environment and take input. and now you processed it with the logic unit, and now you need to also do something about it, right? Like you need like you processed it, and then you need to do some change in the environment. So that is where actuators come in. So yeah, next slide, actuators. Yeah. So yeah, there are the most common actuators are the motors, of course, and there are more actuators like pneumatic pistons and electric, I don't know, electric buzzers and many other actuators as well. But the most common ones are the motors. So let's look at them. So you can see here there are three types of motors. The bottommost one is the typical DC motor. I think everybody probably played with this in their when you have broken RC car or something in your childhood. So that is just a RC motor that spins left, I mean forward and backward. Um, and there is on your right there is a servo motor. So the difference between servo motor and the DC motor is that servo motor is actually a PID controlled DC motor basically, and what it is like you can there are if you see there are more than two wires, so you can give a extra signal that actually you can make the servo motor precisely move a particular degrees. For example, if you give a signal, if you say you want to move 30 degrees using code, you can actually make the servo motor move exactly 30 degrees and then stop. So that is very handy when you need precise movements. And on your left, there is again it is a servo motor, but it is geared, and it it causes instead of moving precisely 30 degrees, it can move precisely 2 centimeters backward and forward, right? So it's just a geared servo motor. Okay? These are the basic actuators. You can look into more actuators in your free time, right? Next. So yeah, previously, like as I said, you have a 5 volt and 3.3 volt outputs in your Arduino. But and I also mentioned that you can actually use those voltages to power your sensors. But that is not the case with the motors, because usually motors take a lot of power. For example, yeah, next. Yeah, Arduino can maximum output of a Arduino pin is 5 volts and 40 milliamp current. Uh, can one of you calculate what is the power like? You have the voltage and current. Just multiply. Hmm. Okay. Yeah. Yeah, exactly. Zero point 0.2 watts. So any motor is of at least 10 watts, 15 watts. Actually, motors usually the voltages start around 9 volts and go all the way up to 36 and even more. And currents also start around 2 amps and reach 30, 50 amps. So that's a lot of power, and none of the microcontrollers are designed to actually, you know, provide that much power. So we need some bridge. That microcontroller is only used to give instructions, and it can't power the motor. So we need something that powers the motor and takes instructions from the microcontroller and combines them, right? So that is what is a motor driver. Okay. Uh, yeah, let's see. Okay, so yeah, let's move on to the next slide. Motor driver. Yeah. So, if you see here, there is a motor driver on the breadboard, and there is a battery bank on the right, and microcontroller on the left, and motors on in the bottom. So, if is a best example for this is like if you have a mobile phone and you have like, I don't know, 1000 watt speakers. Can you directly connect the 1000 watt speakers to your mobile phone and expect it to work like your headphones? No. Um, Obviously you need an amplifier, right? You must need an amplifier. You connect your phone to the amplifier and speakers to the amplifier. You use the phone to give the signal, I mean play the song, and amplifier amplifies it, uses more power, and speakers will output that, right? So motor driver is exactly that. It amplifies the signal, it adds power, and then you sends the signal sent by the Arduino to the motors. As simple as that. So the most used and most common and simple motor driver is the L293D, and we'll see the how it works in the next slides. Next, yeah, yeah. So this is a basic structure of L293D. L293D is very small, like very small IC. It's almost like 2-3 centimeters long. That's it. And so it has eight pins on each side. So L293D can be used. One L293D can drive two different motors simultaneously, right? So left and right are exactly the same, like identical. Okay. Um, so let's start. Let's zoom in. I'll explain how it works. So if you see, there is VCC1 and VCC2. These two are the power inputs, okay? L293D requires two power inputs, one to actually power itself and the other to power the motors. So one of them is 5 volts input and another is the input. It can take from 0 to 36 volts depending on your motor specifications. You can give it, for example, if you have 18 volt motors, you can give 18 volts. If you have 36, you can give 36. Then 5 you can give 5. And another one is fixed, that is a 5 volt input must be given because L293D itself requires some power to run it, right? It is an IC after all. So yeah, those two are done, and remaining, if you see, there are 7 pins on each side which are exactly the same. That is for the left and right motors respectively. So we'll see left side, and the other side is obviously the same. um, okay, so there are two ground pins in the middle, there's obviously the ground, and you connect that to the ground. Like whenever you make a circuit, like please remember this, no matter which circuit, there should be a single ground. Okay, this is very important, or else there will be some problems in the circuit, and I faced it in previously. So whenever you make any circuit, no matter what, you have to connect all the grounds to one and ground it. Okay, so in this case, for example, there are 4 ground pins. So connect all of them and connect to the ground of the Arduino also and the motors. Every ground should be the same. All right. Okay, ground pins are fine. Those are obvious. So we have 5 pins left. Input 1, input 2, output 1, output 2, and enable. Okay. Let's start with input 1 and input 2. So input, obviously, like what do you think input will be connected to the Arduino, and output and output 1 will be connected to the motors, right? A motor has 2 pins, and we also need 2 inputs. Okay, if any of you remember, like in the last session we explained about the um, H bridge, right? um, H bridge also had 2 inputs and 2 outputs. So L293D is basically a dual H bridge integrated circuit. It has 2 H bridges which are completely different, like basically 2 H bridges, and that integrated circuit is made of 2 H bridges. That's it, nothing else. So let's say input 1 is high, input 2 is low, output 1 will be high, output 2 will be low. Similarly, input 1 and input 2 swap them, output 1, output 2 also get swapped, and motor rotates in the reverse direction. And if input 1 and input 2 is set to low, output 1 and output 2 will be also low, and there's no potential difference between 1 and 2, so motor won't spin. Similarly, if you set input 1 and input 2 too high, output and output 2 will also be high, and there won't be difference potential difference, like both of them will be 30 volts for example, but there's no potential difference, so no current, and it stalls. Okay. Questions? Okay. Why should all ground pins be connected to the same ground? So if there is a different ground, if your system has different grounds, there will be different. Um, Basically, for example, one ground is at zero point 0.2 volts and another is zero point 0.3 volts. There will be a current between those two, and it causes some currents which you don't want. So it causes some problems, and your unexpected currents arise, and so like it destroys it interrupts the system, and you don't need that. Hmm. Yeah, all should be grounded, and all there should be only one ground in your system. All the ground pins should be connected to the same ground. That's it. All right. Okay, I'll give you an example. Why do we need enable pin? That I'll explain that part as well. So let's take an example. We have a 10 volt motor and 5 volt input. The L293 works in 5 volts, right? So we need, okay, let's check 20 volt motor. Okay, 20 volt and 5 volt are connected, and input and obviously, what do you think the input will be? Uh, for example, we are using Arduino. So what is the maximum input voltage? If you're using digital pins, we connected digital pins of Arduino to input 1 and input 2. Yeah, exactly, 5 volts. So we can't give more than 5 volts. So, and I also said that we're using digital input, so we can either give 5 or 0. There's nothing in between, right? So let's say I give input 1 as 5, input 2 as 0, and I reference voltage to the motor driving voltage is 20 volts. So what do you think output 1 and output 2 will be? If I say input 1 input 1 is 5 volt, input 2 is 0 volt, what is output 1 and output? Anybody? Mm, yes, it is 20 and 0, right? Correct. So basically, what you can see, right? The motor driver is it's just amplifying the signal and giving the same thing. So if I swap input 1 and input 2, output 1 and output 2 will also swap. And if I say input 1 and input 2, I gave both high. What will be that? In that case, output 1 and output 2 will be 20 each, and there's no potential difference. The motor stops. So how many states are there? There's stop when both are same, and that is 0 0 or 5 5. Both cases, motor won't spin. And if I say input 1 is high, input 2 is low, that is forward motor movement, and in case if I swap it, backward movement. So there are three possibilities, right? I mean, nice. Now I might also need, like, it's okay, you're moving the motor forward, backward, stop, that all right, it's fine. But what if I want to slow down the motor? Can I do that? How will you slow down a motor? What, for example, if you are using a motor without any of these circuits, you have many batteries. Right now you're using one battery. Right now you're using five batteries, and you connected 20 volts. How will you change? Hmm, right? Okay, PWM. Okay, fine. But before that, you need to basically, if you are using a 20 volt motor and providing 20 volts, for example, it's spinning at 100 RPM. Okay, what do you have to change the speed? Yeah, you just need lower voltage, right? So you need to reduce the potential difference between the terminals, and that. So if you need to use 10 volts, so how will you give 10 volts using this L2930? If I give I input one and input two are digital inputs. If I swap the input, that just reverse the direction, but speed won't change. So I need to reduce the my reference voltage. My reference right now is 20 volts, but I need to reduce the reference itself to actually reduce the voltage, right? So that's what enable is used for. So you connect the enable pin to the PWM pin of the Arduino, and so what happens is, like, enable pin and output pin acts as a ratio. For example, in case of I connect the Arduino pin, PWM pin to enable, and I set it to 5 volts. Okay, that's the maximum. In that case, the output voltage is also 5 volts. Sorry, 20 volts. That is 1:4 ratio in this case, right? So if I reduce the PWM signal to 2.5 volts, that is I set enable pin to 2.5. That is, I halved it, right? So even the reference voltage will be halved. At least the output will be 10 volts. The maximum output will only be 10 volts now. So if I want forward movement, I'll give input 1 as high, input 2 as low. In that case, the maximum voltage will be 10 volts. So it enable and the reference voltage always maintains in a ratio. Okay. Maximum enable is 5, and maximum input reference is whatever the voltage I gave, and that works on the same ratio. For example, if I give 30 volts as the output and enable as 5, in that case the whole LT930 works with 30 volts. And if I reduce enable to, let's say, 2.5, in that case the output also, the maximum output reference reduces to half, that is 15 volts. um, Reference voltage is the, as I said, like, I have two VCC1 and VCC2, right? So VCC1 is the motors. I mean, 5 volts that is always used to drive the L293D, and I'll give another. I'll actually connect a battery pack that is actually providing the power to the L293D to run motors, right? That is the reference voltage. Yeah, exactly. So that using the enable pin, you can set the voltage of enable from 0 to 2.5 volts and use it to change the speed of the motor. All right. So you can do how many things? 4 things. You can change direction. You can move the motor in 2 directions and stop it, as well as use it as a speed controller. All right. It won't be very accurate because voltage speed controller is not very accurate. You need some other things, but it's good enough for now. Yeah, correct. Reference voltage to be CC2, yes. We'll be needing to change the sign of the voltage, otherwise how would we? Speed actually depends on the voltage that we give. Depends on the this is a potential difference. Is it positive or negative? If we reverse the connections, motor spins in the other direction. That's it. There is nothing to do with the speed. Speed only depends on the voltage. I mean, it depends on current as well, but you need a current controller, current limiter, and stuff. That requires more. You will get more precise and precise speed control, and that is an advanced concept called PID. And we don't need. We are only doing the voltage speed controller right now. Okay, this can only do voltage speed control. Yeah, I think that is clear. If you have any doubts, please ask, and we'll move on. No, no. Enable one and enable two, you never connect them. Enable one is used to control the left side motor, and enable two is used to connect the right side motor. Those are complete. As I said, you don't. Those are completely different. Those are, you can use one L293 to drive two motors. Hmm. All right. Okay. Yeah, you can answer this question. What will happen if we supply voltage of 250 kilovolts to the VCC of the L293D model? As I said, if you remember, the specification was 0 to 36 volts. What if I give 250 kilovolts? What happens? Yeah, your use a Slido link and answer. Mm, any other questions? No. Nice. All right. Let's look into the what do you think? Uh, see, let's see the responses. Hmm. Okay, that's okay. Module will not respond for the time the voltage is applied. Okay. Nice, lightning. Okay. All right. Uh, right. The answer is damage is caused. But okay. So L293D is a very, very basic integrated circuit. Okay, it doesn't have any safety circuits in place. If you if you give a if you exceed the limits, it will just burn away, and get destroyed. So there are much more smart motor drivers as well in the market, which have safety measurements integrated in it. And if there is a voltage spike, it just shuts down and stops working. And even if you want to use it, you with L293D, you need to add additional safety circuit with L293D, and you can use it to to make the module shut down when there is extra voltage and stuff. But vanilla L293D, it's burned if you give extra voltage. All right. That's all. That's all for the actuators stuff. Okay, so I think you guys are clear with the Arduino logic unit, actuators, motors, motor drivers, and L293T. All right, we can move on for now. Tanmay, you can take over.
Yeah, thank you, Manideep. I'm Tanmay Monti, a subhead at TRS, and I would be taking you along for the rest of the session. So let's start. Towards the end, I would like to tell you some of the concepts and tools that you would be using to connect the dots and actually be helpful while assembling the electronic components into a robot. So now, first, let's look at assembling. First, I'll tell you about breadboard. So breadboard is nothing but just a grid of holes. Can we zoom to the breadboard? Yeah. So it's just a grid of holes and it makes it very easy for you to make electronic circuits. You just have to push the pins of the electrical components or the wires into it and connections are made. Simple, right? This does not require any kind of soldering from your side to make electrical connections. There is just one more feature to it. As you can see, we have connected various holes using red lines. This is because they are internally connected. That is, if you connect one wire to one of the holes on the same row as the red line, then you can access the connection from the other hole. The vertical lines numbered 1, 2, 3, 4 are usually used to make electrical components, to connect electrical components like LEDs, resistor, or even Arduino. And the horizontal lines, which are also internally connected, are named plus and minus because they are usually used to power the circuit using an external power source. So the numbering A, B, C, D, sorry. The numbering A, B, C, D and 1, 2, 3, 4 help us to locate a particular hole in case we want to connect it at a specific location. So all these features actually makes it very easy for us to make electronic circuits. So next up, we have the soldering rod and solder. Solder is nothing but just a special alloy with a very low melting point. Sorry. Yeah. So soldering iron becomes very hot when you switch it on and it melts the solder and you apply the molten metal onto the joints that you want to connect. On a light cooling, on leaving it for some time, it makes a very strong but permanent kind of joint. So things are actually quite irreversible and thus there's an easier alternative to this, that is jumper wires. These wires have two kinds of ends. On one hand, it has holes on it where you can insert the pins that you have seen in various electrical components. While on the other hand, you have pins to it which you can connect into you can insert into Arduino or other breadboards. So this makes things quite reversible. And even if you make a mistake while connecting, you can just disconnect everything and reconnect it. Simple, right? So next up, I want to tell you about LM7805. Don't worry, it is just a voltage regulator. Yes, so LM7805 is a voltage regulator. The last two digits, 05, tell you what is the output voltage. It is a very important component. You know why? Because whenever you make a robot, on one hand, the motors require somewhere around 12 to 15 volts. On the other hand, sensors and Arduino work around 5 volt. So instead of using two kind of batteries, one higher, one lower, we just use a higher voltage battery and use this voltage regulator to bring the voltage down for other purposes. So as you get from the nomenclature, I would like to ask you, what should be the output voltage of LM7809? You can write in the chat box. The nomenclature is simple and same for every voltage regulator. Let's see if you understood. Yeah, 9 volt. Great. So that is the function of LM7805. On the specification side, you can convert somewhere around 7 to 25 volt to 5 volt and use it for various purposes. So I think let's move on to the next slide. Any electronic circuit requires two types of signals. Yes, these are the digital and the analog signal, and I'll first tell you about digital signals. Okay, so digital signals are nothing but they are the signals which takes just two discrete values. One is called low or zero, and the other is called high or one. As you can see from the graph that is made on the left, which has some pulses of high voltages at some point of time. So what happens is that there are some sensors which produce digital signals or work on the concepts around digital signals, and there are other sensors which work around analog signals. And Arduino can handle both of them. Two components that you have seen earlier, that is the ultrasonic sensor and the LEDs, both work on the concepts of digital signals. I would again like to tell you the working of ultrasonic sensor in brief. Okay, so what happens? There is a trigger that we send to send signals out of the ultrasonic sensor, and a trigger is nothing but just a high pulse, that is 5 volt pulse to the trigger pin. It sends the signal and receives something. And whenever we sense a 5 volt high voltage pulse out of the echo pin, we say a detection is made. That is, something is found within the specified range we programmed into the ultrasonic sensor. That is how ultrasonic sensor works. And similarly, as you may know, LED works only when one pin is at low voltage and the other is at high voltage. So now let's look at what is analog signal. Analog signals are also similar to kind of things. Just the difference is that they are continuous in nature. Continuous means within a specified voltage range, let's say +5 to -5 volt, it can take any kind of value. It can even take 0.5 and any kind of decimal value. I would like to tell you an example that on the right, as you can see, there's a potentiometer. Potentiometer helps us to get a value between a lower limit and a higher limit. If you the lower limit that you want must be connected to the right pin, and the higher limit that you want must be connected to the left pin. And based on the position in which you keep the knob, it takes a value between lower limit and higher limit. So that's how we get a whole range of voltages out of potentiometer. As Manideep has already told, Arduino can handle both analog and digital signals. There are actually 6 pins for analog signals and 15 pins to handle the digital signals. So that's all I want to tell you about the signals. And I want to ask you to quickly answer a quick question. So which of the following components will you connect to the digital pins of an Arduino? So to answer this, you may click on the link of Slido on Teams as well as YouTube chats, or you may write the poll code on slido.com, or you can also scan the QR code. You can also ask your questions. I am there on the chat box. The options are potentiometer, ultrasonic sensor, light dependent resistor, and input pin of L293D. Okay, I want to tell you that this question may contain multiple answers, so please mark accordingly. Slowly, we are gaining more responses. Okay, we have received 30 responses. Actually, you can program both kind of pins. You just have to write different kind of code to handle digital pins and different kind of codes to handle the analog pins. All pins are programmable on an Arduino. Okay, can we look at the responses? I guess we have just crossed 50. Can we have a look at the responses? Yes, so I guess you all are paying a lot of attention. Ultrasonic sensor, as I just told you, is the correct answer, along with input pin of L293D. Kudos to you. Ultrasonic sensor is, I just told you how it works on digital signals. Input pin, as Mandeep told, also works on just two kind of voltage values, the high and the low. That's why it's also considered as a digital device. So let's move on. I hope that you all would keep these things in mind while assembling your bot, and this would be really helpful and would help you reduce your bugs that you make while assembling a robot. So finally, we all are very excited to announce a surprise we have for you all, which is, yes, the Freshers Kit. We have observed that due to pandemic, many of you are really interested to make robots and practically apply all the things that you have learned by joining in the components and actually see your robot work according to your program. But pandemic has made it very difficult for you to access all this and the facilities we have at campus. So Technology Robotix Society has launched Freshers Kit, which includes various components, which with the help of which you can make a lot of projects. It has been handpicked by us to cover almost all the things you would like a basic robot to do. And this would be very helpful for your DIY projects that you all have to make in your first year, as well as Technology Robotics Society conducts Winter School of AI and Robotics, as well as many hackathons which require these components to practically solve those and make robots out of it. So let me show you the component list. We have picked these components accordingly about what we have taught you, like Arduino Uno and its cable to power it and to transfer data from your laptop and input the program into Arduino Uno. There are two motors. There are a motor driver that you just read, which is L293D, used to power the two motors. We have also added a metal chassis on which you can just mount the things together along with the caster wheel, so that it makes a very sturdy support to everything you keep on top of it. There are other things that you have learned today, like breadboard, jumper wires, and ultrasonic sensor, of course. Ultrasonic sensor, you can just make a simple bot that I'm going to show you. Have also included the 12-volt adapter. Adapter is used to power your robot in case you want to make something autonomous, but you don't want to connect batteries. You can just connect it to the plug point you have, and it would give power to the Arduino. So I guess you might be a little confused about what all can be made only using these components. So I would like to show you two videos of the projects we and our seniors made in the past years. So let's move on to the first video. Yes, this is a line follower robot our seniors made, and it is present at the campus. And I want to tell that all of it has been made using the components that has been mentioned in the previous list. The second video is actually a very interesting one. It is an obstacle avoidance robot. It uses an ultrasonic sensor as sorry, as you can see in front of it to judge whether an obstacle is present in front of it or not. And based on the input that it gets by looking on left and right, it just decides that whether to go forward or not, and protects itself from crashing in with something. Yeah, so I think this made you highly interested in making these projects on your own. And of course, the possibilities are endless. Let's move to the next slide. You can always come up with your self-project ideas, and you can always message us in case you need any help in assembling the things or any project you want to make. So to make this possible, we have actually partnered with Pots and Chips, which is an electronics component store based at Kharagpur. to bring this to you at competitive prices. The final price along with the component list would be posted on our Facebook page. Um, and this kit can be ordered on the website of Bots and Chips, and we would tell you the procedure how to order it. It is not compulsory to bring the bots to buy the components from Bots and Chips, but we have designed it as a one-stop solution to all your problems, so that you don't have to look for the components individually on different websites or different online stores. So, in case you don't feel satisfied, there's also an option that whenever you come to the campus, you can return the components for full refund if they are intact and in working condition. In case you want to build something advanced out of it and want more advanced components such as extra sensors or extra modules to attach on top of Arduino, you can always message us, and we would help you to know how to get them accessible. So yeah, with this, we would be releasing the post regarding the kit soon on our Facebook page. So keep an eye on that. And we highly recommend this freshers kit to actually practically apply the things. When we received the kit, and I personally made a WASD bot, it was surreal for me to actually look that my code actually works and the robot dances on what I have written and what I have inputted. So yeah, it helps us to get a very steep learning curve, and by applying what we have actually learned. If you have any doubts, you can always contact Nikhil Giri, whose number is present here, or you can contact Bots and Chips, and you may take the screenshot for further reference. I'll wait for some time. Many of the when we were freshers, many of our friends also made a robot out of this, and hundreds of students sent us videos of their projects they made in winter school, and it was really an enjoyable experience for us all. So yes, I think we can move on. With this, we almost come to the end of this session, and we are now open to your doubts, and this would be followed by a virtual hands-on session for you all. Yeah, Venkatesh, we would give you the component list with all the details that would be included on our Facebook page. So please keep an eye on that. And yes, it can be delivered all across India. No issues. Winter school, we would release a separate post regarding winter school at a later stage when you all would be relatively free to attend longer sessions. Yes, you can always, if you found that these are not working, you can always contact the store and get your queries resolved. Yeah, so with this, I now hand over the presentation to Ajay. Thank you so much.
Hello everyone. Hello again. So, hope you got very much interested in autonomous robotics now, and now you have seen in the freshers kit and all. So, like, I would like to once again specify that freshers kit was really very useful for all our batch, and especially for the DIY and many other projects which you can make. Especially the scope of projects which you can make with freshers kit is enormous. Okay. So coming to the virtual hands-on, so we'll be conducting this. You might already be knowing that you're added to the another team called virtual hands-on of K.R.A.I.G 201. So, and you already might be knowing which channel you are allotted. We shared a doc in the mail, and so after this session, you can just hop onto that. So before starting that, let me tell you that we'll be doing this virtual hands-on using a software called Tinkercad. So the ones who have DIY this might already be knowing what Tinkercad is, but for the ones who don't know, it's okay. We'll be giving you a demo of Tinkercad and many basic functionalities of Tinkercad. The ones who know, it will be a good revision for you. So yeah. And you'll be having specific tasks for the virtual round, and for each session, I mean for each channel, you'll have a mentor. So always feel free to ask any doubts which you have to your mentor. Okay, so I'll give you a short demo of Tinkercad now. So yeah, hope you can see my screen. So you can just go to tinkercad.com, and hope you all have made your accounts on Tinkercad already, as it was mentioned. You can just log in with your Gmail account in Tinkercad. So once you log into it, you can go to circuits over here, and you can start with create new circuit. So this is the UI which it will show you. And so basically, for using Tinkercad, you need not download anything. It's a complete open source online simulation software, and you need not download anything. Just make an account, and once you create a new circuit, you will automatically get a blank circuit, and you can just rename your file over here, for example, something like this, and it will get renamed, and all changes will be saved at all time, and you'll not save anything. So here is a list of components. So you have many components like resistors, LEDs, push buttons, potentiometer. Okay, and you can just search here for any components which you need. For example, Arduino Uno. You can just drag like this. You can just hold this and drag here, and let's say a breadboard. There are different types of breadboards. Small breadboard is enough for now. Okay, and connections in Tinkercad is really simple. Like you can just just hover on one of the holes, and you'll see highlighted, right? It's highlighted, right? So you can just click it, and you'll get the wire in this way. You can just hover on some other block and click once again, so that will make a connection. Yeah, hope that's clear. So that's really simple. And so for the tasks, I'll explain you once again in detail, but for the tasks, we'll be giving you all the components, and the code of Arduino Uno is written. You need not worry about the code, but just to give you a feeling, so when you click Arduino and click code over here, okay, it will give you, you can just choose block text over here. So this is the code of the Arduino, like it's the built-in code which it already has. It's just a blinking LED code. So you need not worry about the code at all. Okay, and we'll give you all the coded Arduinos already. So you just need to make the connections and get a feel of how the bot is working. Okay, so let's make a small circuit. Just connect an LED. And let's say a resistor. You can just click on R, then the components will start turning. Okay, so you can just click on any dot, and it will give you the wire. So this was positive terminal. Okay, something like this. Okay, I hope that's clear. Yeah. So let's see if it works or not. So the code is already written. You can click on Start Simulation. Yeah, so I think you can see the LED is blinking. Okay, and you can control, I mean, okay, let's leave the code for now. So this code is based on that. So you can, I would really appreciate, I mean, encourage you to go through the code, try to understand. But if you don't understand also, it's fine. Like after you go through the PDS in your first year, you'll easily understand it. Okay, so that's it for this thing. I mean, any components which, if you are not sure what it is, just search it there. I mean, you'll get a component and you need to simply use it. Okay, so any doubts over here? Let me see the chat box. Okay, so how did you pend? Yeah, you can just click it again and it will remain there. Okay. Okay. Uh, Fine. Any other doubts? Maybe we can go back to the presentation. How does a photoresistor work? Okay. Like, do you mean a light dependent resistor? I guess you mean a light dependent resistor. So the value of resistance basically changes depending on the light which is incident on it. So that's how it works. Okay, so hope you know now how to use Tinkercad. Okay, so let's see what tasks we'll be doing in this virtual hands-on session. So we'll be sharing with you a doc which will contain very detailed instructions of each of them. So don't worry if you missed anything in this presentation. So we'll be sharing a doc which contains everything in it. Okay. So for each problem statement, for task 2 and 3, we'll be giving you a template of Tinkercad also. You can just use that template and make the connections directly. And so you'll be, as you all know, you'll be divided into groups. You have 10 channels in that team which you are added in, and you might be knowing already which channel you are uh, from the mail which you got. Okay, and always feel free to ask any doubts which you have to your mentors. Okay, let's check out task 1. Okay, so in the task 1, we'll be implementing a hedge bridge using L29 3D IC. So I guess Manideep explained what L29 3D does and all that. So in this task, we will be controlling two motors independent of each other. Like for example, you can move both the motors in the same direction. You can turn off one motor. You can move one of the motor in a reverse direction. All possibilities. Okay, where you can control two motors independently. So you'll be doing that. And here is a list of components which you'll be using. And you can just search them on Tinkercad. It's very simple. Okay, fine. Uh, Next task. So the next task is a really interesting bot. So you'll be building an object follower bot. Okay, and you can visualize the bot to have two sensors, two ultrasonic sensors in the front, and it needs to follow these basic points. And once again, don't worry, we'll be sharing a doc which will contain all the instructions you need to do to build this bot. Okay, and so it will have two sensors, and if both the sensors detect an object within 100 centimeters, both the motors of the bot should move forward. And if one of and if there is no object in front of it for 100 centimeters, it can stop because there is no object in front of it. And if the left sensor detects something before 100 centimeters, but then it can stop, right? Because only the right motor can keep working, and the bot will turn left so as to follow the object which it detected. Okay, so that is how an object follower bot works. And for this, you'll be using two ultrasonic sensors, and the rest of the circuit is very similar to task one. So keep an eye on that. Like it is really encouraged for you to follow the task in the order in which they are. So you'll be using the circuit which you did in task one and task two. Okay. You can ask any doubts in the chat box anytime. Let's move to the next task. So the third task, you'll be implementing a home automation system. So it's like a little reduced version of it. So you'll be implementing only three characteristics of this home automation system. So the door should open if you find anyone within 30 centimeters in front of it. So, I mean, you have to visualize what you'll be doing. So for the door, we'll be using something called a servo motor. If you don't know what it is, it's okay. You can ask your mentor in the group. So we'll be using a servo motor and ultrasonic sensor. Okay. And the second feature is the LEDs in the room should light up if you find any movement inside the room. So for this, we will be using something called a PIR sensor. It's a passive infrared sensor. So any doubts, you can ask in the mentor room anywhere. And the third feature is the fan should switch on if the temperature of the room is about 25 degrees Celsius. Okay, and here in this task, I would like to stress this point that most of the times you might be thinking an autonomous robot might be something that physically has something called motors. It has to follow something. It has to maybe avoid some objects or something. But even this, a home automation system, the system as a whole works as a single robot. So the entire framework is a single autonomous robot. So autonomous robots can have many different ways. So you can think of many different robots which does not look like an autonomous robot in the first glance, but actually works autonomously without any control from the user. So yeah. Any doubts till now? Uh, you'll be shared a doc. Yeah, I think we can share the doc now. Okay. No, channel 2 has task 2, not like that. Each channel is independent of each other. Like in each channel, they will be done task 1, task 2, and task 3. Yeah, you have to just follow the instructions in the doc. And any doubts, just ask your mentor. Deadline, you can decide this with your mentor. It's totally up to you. Like if you want to stay in the session as long as you want, but try to complete it as fast as possible. Because after one point it becomes difficult. Yeah, you can always ping any of the mentors at any time, even after the session, if you have any doubts. just ping them, they'll answer it. Yeah, we'll be sharing the doc soon. Okay, like let me just once share my screen maybe and show them the doc. Will that be okay? Okay. Okay, so this is the doc which we'll be sharing with you, and we'll be sharing with you. I mean, it will be soon shared with you in the link. So in the task, I mean, you have like task one, you'll have a short description and components. So you can just search them on Tinkercad and get them easily. So in the task one, you have to simply, you know, make this circuit once again and see whether it's working, feel how it's working, how it works autonomously. I mean, this does not work autonomously, but feel the working of L29 3D. Okay. And so this is the task two. It's object following bot and have a short problem statement, few instructions. Okay. And all the pin configurations. So go through the pin configurations carefully. And see, for each task, you will be provided a Tinkercad template. Okay, for task 2 and task 3. For task 1, you need not have a Tinkercad template. So for task 2 and task 3, you have Tinkercad templates. So just click on it and copy and tinker. So that will be good. And so here is the task 3. Okay.
Okay, I guess if there are no more doubts, all of you can switch to the hands-on session team. We'll share the doc on all the channels there. Join the other team. All the docs will be shared there.
Okay, thank you everyone for the session. Hope you liked it. You can join the virtual session now.
You can leave this meet right now.